In this video, you will learn how to estimate battery life based on actual power measurement of your device and battery discharge profiles created in Otii, generated with an external profiler, or provided by a colleague, manufacturer, or partner. The estimation runs in 4 steps. Measure the current profile of your device under test, build a device profile from that measurement, select a battery from your profile database, then run the estimator. Let's go through each one. Start by recording the power consumption of your device in Otii. Once you have the measurement you need, it's worth adding selection for the different activity states, like sleep, transmission, boot, whatever applies to your device. You will use those selections directly when building the device profile in the next step, so having them named and marked saves time. Open the estimator from the toolbar. In the window that appears at the bottom, click Create New Device Profile. First, give the profile a name. This will be used to identify the estimate created. Then, define the operating voltage range for your device. In this case, 3 volts as the cutoff and 4.5 volts as the maximum. This sets the voltage threshold at which the estimator stops. Next, define the average sleep current. You can type a value directly, make a temporary selection, or click a Save Selection and use the Sleep from Selection button to pull it from your recording. Select a relevant measurement that is going to be used for the estimation. Then, add the activities your device performs. In this example, there are 2. Select each one from your saved selections. Once added, you will see a graphical representation of each activity alongside its scheduling configuration. Delay sets how long after boot the activity runs for the first time. Every sets the recurrence interval. For example, activity 1 is delayed 4 hours from boot and repeats every 4 hours. Activity 2 starts at boot and repeats every hour. Move to the battery profile step. Here you will pick the battery profile to run the estimation against. The selection interface is the same battery profile manager covered in a separate video. The same compare, export, and import actions are available here too. For this test, I am interested in identifying the most efficient alkaline battery for my specific device profile. So I will start with the Duracell AAA. Once selected, the discharge curve and full profile details loads within the estimator. On the right side, you will also see the option to configure a battery pack, which is relevant here since this profile was created for a single 1.5 volt cell and my device requires 4.5 volts. So I will set up a pack with 3 cells in series. Keep in mind that the battery pack configurations are automatically filtered to stay within the maximum voltage you define in the device profile. You can also set a self-discharge rate and interval here if that's relevant to your use case. In the final step, you will see a summary, device profile name, and battery profile that will be used. Click Estimate Battery Life to start. Depending on the configuration, this can take a moment. While it runs, the Estimate Battery Life field shows a running indicator, 3 dots cycling, and the battery voltage curve builds in real time on the graph. To get a cleaner view during this step, hide the active measurement channels and show only the main voltage for the device simulator. Once complete, you will see the estimate battery life in time, along with the reference to the battery capacity consumed. In this case, we got an estimate battery life of 241 days and a use capacity of 59%. You can also click on the simulation just created to see more details on the activity configuration that produce it. The idea is to identify the most efficient alkaline battery for this device profile, and this is where the continuous validation workflow speeds up the selection process. From the same estimator session, go back to battery profile, swap the selected profile to a Vara AA battery, and configure the pack with 3 cells in series. Now, you just need to run the estimation again and the new results appear alongside the first. You can immediately see the difference. The Vara AA gets an estimate battery life of 624 days and a use capacity of 67% compared to 241 days for the Duracell AAA. Translated into efficiency over the product lifespan, that's an 88% increase. Run as many estimations as you need to validate the system performed as it was designed to. They are all safe in the OT project, so you can share the full analysis directly with colleagues, partners, or suppliers. To start using it, update OT to its latest version and enable a battery toolbox license.